In this lesson, we'll review how to write the names and formulas for ionic and molecular compounds. Before naming or writing the formula of a compound, you must determine if it is ionic or molecular. Different types of compounds have different sets of rules or notations for writing the names and formulas. Let's deal with ionic ones first. Remember, you recognize these by seeing a metal bonded to a nonmetal or more than one nonmetal. For writing formulas, we use the crossover or crisscross method. The first step is to find the charge on each element or a polyatomic ion if present, and then cross over the charge numbers to make them quantity numbers. You use brackets to designate more than one polyatomic. Remember, polyatomic ions are usually treated as a single unit because they move as a group. The final step for writing ionic formulas is to reduce the quantity numbers if possible. Here are a couple of examples. If my compound is magnesium fluoride, I would look up on the periodic table the symbol and the charge for each of my elements. Then I would apply the crisscross method. I would take the 2 from the 2 plus and I would write it down and across, and I would take the 1 from the 1 minus on the fluorine and move it down and across. I would then get Mg1F2. You only crisscross the numbers, not the plus or minus signs. Chemists don't usually write ones. If you write down Mg, it signifies that you have 1 magnesium. MgF2 is in the lowest possible terms, so the formula for magnesium fluoride is MgF2. Pause the video and try out the other examples. For magnesium oxide, magnesium has a 2 plus and oxide has a 2 minus. When I crisscross these numbers, I'm going to get Mg2O2, but then I can simplify that into MgO. Silver nitrate involves a polyatomic ion. Remember, you can recognize these by not ending in IDE. There's a chart on the back side of your class periodic table to help you identify the names and formulas of polyatomics. Silver has an Ag with a 1 plus charge, and a nitrate is an NO3 with a 1 minus. If I crisscross these charges, I get AgNO3. There's no need to put brackets around the nitrate because I didn't cross a number over top of it. AgNO3 is in the lowest terms. The last example shows us a stock system name. The 3 in Roman numerals in brackets in the middle of the name tells us what charge to use on the iron. Some transition metals have multiple charges. For example, iron can exist as a 2 plus or a 3 plus. The Roman numerals tell us to use 3. If you don't know based on the question what charge to use the most common charge. It's listed first on our classroom periodic table. A sulfate is a polyatomic SO4 2-. When I crisscross these numbers, I'm going to put the sulfate in a set of brackets. Fe2 bracket SO4 bracket 3 is in lowest terms. I can't reduce the 2 and the 3 any lower. Naming ionic compounds. Step 1. Give the metal its full name. Step 2. add a Roman numeral for metals that have more than one charge. Sometimes you need to figure out what charge is on the metal by looking at what it's with. Step 3. If the ending is a nonmetal, name the nonmetal and change the ending to IDE. If the second part of the ionic compound is a polyatomic ion, leave the poly name. Don't change any spelling. For example, if given the formula FeCl2, I need to determine what's the charge on the iron. Is it 2 plus or 3 plus? Because I have 2 chlorine ions attached to it, and each chlorine is always a 1 minus, then the iron must have been a 2 plus. One tip to help is that the charges in all ionic compounds always have to add up to 0. I would name the metal iron, include Roman numerals in brackets for the charge 2, and then change chlorine into chloride. Pause the video and try to name the following compounds. Here are the answers. NaCl is sodium chloride. PbO is lead 2 oxide. Lead can either have a 2 plus or a 4 plus. By looking at what it's with, I can figure out it's a 2 plus. Oxygen always has a 2 minus charge. The formula PbO was reduced as part of the last step of writing its formula. BaSO4. The metal is a barium, and SO4 is a sulfate ion. PbO2. I have lead again. Oxygens always have a 2 minus charge. Now because there's 2 of them, then the lead has to balance a 4 minus charge. So this is a lead 4 oxide. You can recognize molecular compounds by having 2 or more nonmetals bonded together. Because there's different combinations for the same elements sharing electrons, the names of molecular compounds include how many of each atom you have by using what's called a molecular prefix. If you have one of that nonmetal, a mono is used, 2 di, 3 tri, and so on. The steps for naming. Step 1, give the first atom its full name. Then use a prefix in front of that name to indicate the number of atoms that compound contains. Now mono does not have to be used on the first element, but it does have to be used on any other element. Step 2, give the second atom its full name and add a prefix on that to indicate the number of atoms. Step 3, change the ending of the name to IDE. For example, if given the formula CO2, the name would be carbon dioxide. It contains 1 carbon and 2 oxides. Monocarbon dioxide technically is also correct, but the mono is not necessary in the name because it's on the first element. Try to name these 2 examples. Here are the answers. S2O is disulfur monoxide. If you ever have a mono oxide, one of the O's gets dropped. C3H8 is tricarbon octahydride. When you're writing formulas for molecular compounds, you use the name to determine what elements you have and record the symbols. Then you use the prefixes to determine how many of each atom you have and write down your quantity numbers. It's important to note you do not reduce molecular compounds as the last step. Here's an example. Phosphorus pentabromide. I have a phosphorus, so the symbol for that is P. Bromide is a bromine. Remember, the last three letters of all the names are changed to IDE, so change them back to the original elements. So a bromine has a symbol Br. Because there's no prefix in front of the phosphorus, I only have one of them. And because there's a prefix of penta, that means I have 5 bromines. And again, I don't reduce my quantity numbers. Try out these two examples and see what formula you get. Here are the answers. Dichlorine monoiodide. I have a chlorine and I have an iodine. Because of the dichlorine, I'm going to put a quantity number of 2, and the mono means I have 1 iodine. Chemists don't usually write ones. My final formula is Cl2I. Dicarbon hexahydride. Carbon is a symbol C, and hydride is the element hydrogen, H. The di means that I have 2 carbons, and the hexa means that I have 6 carbons. The final answer is C2H6. Do not reduce this to CH3. Try out the homework worksheet on writing names and formulas for compounds.